look at the final words on the IRR. The bottom line on IRR is that we should not be using the IRR to pick up the projects, because it can be dangerous. Depending on the amount of the investment, the IRR may give you false results. So it's always better to use the NPV. IRR can be used as a reference point at what rate the NPV will become zero, to understand the sensitivity of net present value. So IRR is not the primary method to make a decision. NPV is. IRR is useful in understanding the sensitivity of NPV. Now let us understand one more example where we are going to choose the project with different lives, right? So how do we choose? Now here you have an example of one project where you have project A is gonna give you the year project PV at zero, right? You're gonna pay minus 10,000. So here is a network server solution. So your initial investment is $10. After that, you have to pay $1 each for the next 3 years. Project B, you are investing $7, and after that, for each 2 years, you are going to pay $2 each. So the NPV, even though it's lower in the project A or project B, which one you will choose? Because remember, the size of the server is different. In this case, we normally calculate the annuities. So how do we calculate the annuity? In the initial slide, we teach you the way to calculate the external equivalent annual annuities, EAA. Once we calculate the equivalent equivalent annual values, we understand that year one, the annual value of the amount is only $5, and annual value of $10 of PV of 10 project B is $6. How do we calculate that? The calculation method is, first we calculate the present value, so which is 12.49 and then 10.47, and then we will see what would be the equivalent of this value at the same present value 10% in 2 years, because this is 3 years. So we will use this as an annual cash flow present value. Now how much is equal amount in 3 years at the 10%? The formula is, we'll show you now formula. So in this problem, again, we have another option, the project C, which is going to approach with another option that lasts for 4 years. And the cash flow is minus 14, minus 1.2, minus 1.2, minus 1.2, and minus 1. Right? So how do we calculate that? The formula remain the same. The first we will calculate the NPV at 10%, and then we will calculate the annuity for 4 years. So the way to calculate this is here. Formula for the first one is already that minus 14 divided by 1.2 divided by 1.1 and times 4. Then you can calculate the annuity, or you can calculate it this way as well. This is another shortcut formula for calculating the net present value, where the amount of cash inflow is the same. So here the NPV is, the net present value is 17.8, even though it's much higher than the earlier projects. Once we calculate the annual PV, so the formula for annual PV is this: equivalent annual annuity is PV divided by 1.1 divided by R, 1 minus 1 over 1 plus R to the power of n, which is 4. So here you can see minus 17 divided by 1 over 1.1, and then in the bracket 1 minus 1 over 1.1 times 4. Once you solve this, you get minus 5.62, which is higher than the project A. So even though we are spending a higher amount in the initial year, but the life is 4 years, we should not choose, because we are getting a not so good project, not so good value at $5. So the annual price of this is 5.62, which means we are not going to take. But even in these cases, you have to remember a couple of things. One is your required life, means what is the real life of these equipment. Even though the contract may be for 4 years, what is the useful life? And the second thing is what is the replacement cost of this? So what happens after 2 years? What happens after 3 years? and what happens after 4 years. If the replacement cost is different, means not the same, then definitely the decision will not change. But if it's different, decision will change. So you have to factor in the replacement value. So whenever we are making the decision where the different life of the assets is given, you have to see what is the replacement value, what is the replacement cost, what will be the renewal cost after that particular life. And then apart from the other quality constraints, these are the decisions that you will need to make and make a decision.